Now let's proceed with question number 3. It's on current electricity. We have a battery of EMF 12 volt and internal resistance of 2 ohms. It is connected across a variable resistor of resistance R. What value of R allows maximum power to be transferred to the external resistor, and what is the maximum power? So to transfer maximum power to an external resistor, what happens is that the value of the resistance of this resistor must be the same. The value of the resistance must be the same as the value of the internal resistance of the cell. And that implies that the two of them have to be equal to 2 ohms in that case. And so we can easily get the current here that is going through that external resistor using the fact that E equals I multiplied by R plus R. So in this case, EMF is 12 volts and I is what we're looking for. R plus R, that will be 2 plus 2, and that will be 4 ohms. So therefore, if you solve for current in this place, you have 12 divided by 4, and that is going to be 3 ampere. So the current here is going to be 3 ampere. So to get the we know the current now, and we know the resistance. The resistance has to be 2 ohms. Then power is going to be IV, where V is the terminal PD in this situation. But I do not necessarily need to use that. I can also use I squared R, since I don't want to have to do for my terminal PD. So what's my I? That is 3 squared. 3 squared. And what is the resistance? Resistance is 2 ohms. So multiply by 2. 3 squared is 9. 9 times 2 is going to be 18. So we have 18 watts. So the correct answer to that is going to be option A. Option A. A resistance of 2 ohms and a power of 18 watts in that external resistor.